Videoland is Friday edition of physics class, and we're revisiting and reflecting on the concave mirrors, which we finished that work, but I just want to ask you a question or two about it. And that is, can you think of a practical use for a concave mirror? We've talked about how they work and how their images form. Cars? Is that what you said? Why? Right, so like if you had a car here and you wanted a headlight, notice that we don't take a bulb and put it out in front of the car because the light would go in all directions like this, and some of the light would go in the direction we want to see, but some of it would go into our eyeballs as drivers at night. That's not a good idea. So you have all kinds of light going in all kinds of directions. So as Zach mentioned, let me see if I can, these tissues work any better.
Brian has some.
Okay, let me borrow a couple of them. I had a big box when I left, and I can't find it, so.
It might be in the math room.
I think I looked there as well. Maybe I didn't, but okay. All right, so what we do is inside of every headlight in your car is a spherical mirror, maybe even parabolic to be the best. And the light bulb is sitting in there, guess where? Right at the focus. Because all the light that comes out, some of it's going to go out in the direction we want, and that's fine. But what happens to every light bulb, every light beam from a bulb that goes from the focus to this spherical mirror? It always comes back horizontal. So all these light beams are going to go like that. So there's a practical spot that we do use these mirrors. Anywhere we want to direct light in a certain way. What about the other way? What about the sun is so far away that by the time its light hits us, it's practically parallel. It isn't really, because it's coming from one source, so there's a slight angle, but for all practical purposes, it's hitting this mirror in a parallel form. So what happens to parallel beams when they hit a spherical mirror? They all come back in one spot. So why would we want that? If we want that, whoops.
Solar energy.
Right, so we want to collect solar energy. That's one, or warm something, or light something. So this also works. Spotlights are going to take this kind of idea. So there's some practical spots where we see concave mirrors. All right, here, what was I going to talk about that? Oh, I know. So here we've seen, what are these two dots, do you suppose? I didn't mark them. MK, what's this one? Right, and then this one? All right, so they relate like that. So on a concave mirror, you recall it goes in parallel, back through the focus, in through the focus, back parallel, and then one from the radius comes back. So here's my famous triangle. We should name it after me. They're supposed to intersect at a point, and when we do that, we get an upside down image, and we've got, looks like this one is reduced. And somebody asked me somewhere along the line, not sure I answered it, was, well, how can I see this image? Is it just floating in the air between the object and the mirror? It sort of is, but how will you see it is you got to put a screen right there. What kind of screen? You can put a pillowcase or a piece of paper, or a sheet, or a real screen. But if you put a screen right here, you can catch that image. And we'll do a little bit of something like that to convince you in lab next week. All right, now this one, what spot is this again, MK? Focus. What was odd about this one is I actually put the object on the focus. And I'm sure you're curious about what would happen if I did that. We're always putting them in front of or behind. And look what happens. We can't really go in from the focus because it's on the focus, so that doesn't work. But we could go from the radius. We can do that light beam. And what other light beam could we do? No, we can go from the top through the focus. but we can't do the one through the focus and back parallel because it's sitting on the focus. So these two rays will do. And do they intersect down here? Do they intersect back here? They do not. So believe it or not, when you have an object sitting on the focus, it's blurry. You can't see it. It sounds like the word focus. You'd see it crisp and clear, but it's the opposite. You do not ever get an image if the object is on the focal point. So I thought that was an interesting point to realize. So those are some reflections on concave mirrors, and then we advanced, or at least progressed, to convex mirrors. And we found that they worked a little bit differently. So we're going to bend it this way, where this is the reflective surface. We still had an optical axis. And you remember how they were any different. So how will I set this? Say I'm going to do this practice problem that we were supposed to do in class yesterday. If you didn't finish it there, you were asked to finish it at home. Can you tell me what's different about this than, say, the way I did this one, MD?
So the object is still on the left side of the mirror,
Okay,
but
I'll put the object still in front of the spot that's bending toward it. It's not caving in on this object. Yeah.
but the radius and the focal point are on the other side.
Right. All right. So I'll put one in here and here. Let's do this problem. So the object is at 5. And the radius is at 10. Alright, well I get a volunteer to tell me what to do. Can you look it up, see what you got for this one? It was practice problem number 3. It was on yesterday's daily work. And you were asked to finish it at home if you didn't get it in class. So we have the object at 5, the radius is 10, so that means the focus is at 5. Alright. So would you talk me through, what was our first ray? A blue or red? I can't recall what I did. I'll just do a different color for each. All right, Zach?
I think the radii was 5 on this one.
It was? Oh, okay.
Ours? 6.
Wait,
It's
no,
six.
it's 6.
You have
It's 6.
6.
It's 6.
It's someone, what?
It's 6.
Okay, so I got the wrong problem. 1, 2, 3, 4, 5, 6 is the radius. And so then the focus is at 3. All right, Zach, so walk me through the first ray that I want to go in parallel. What happens when I hit the mirror?
You have to go diagonally from the focus to the top, yeah, to where that intersects.
So it's going to go in horizontal and it will reflect at that point. It can't go through the mirror, but it will reflect as if it's coming from the focus. So like that, and that's the darker reflected arrow. All right. So, Alex, you take me into the focus. So I'm going to head for the focus. And when I hit the mirror, so if I would have kept going, I would.
You dash the thing.
Yeah, I'll take it in as if it's going in. And then how will it reflect at this point?
You go back out.
Right. In what form? Looks like you were drawing it in the air correctly.
Yeah, it's going this way, down.
Down?
No, not straight down. It's going.
It's going to go toward, this one went in parallel to this one.
And go out, up, and,
And
the
up,
other one's
and-
going to go down.
This went in
Reflect back.
parallel and out through the focus. This is going in through the focus, so it's going to go out parallel. Right. All right. So that's my rendition of parallel. Forgive me.
Okay.
All right. And what about the third one? Where will this head for?
Like it's going to go through the radius.
So I'll head toward the radius. And where will it reflect?
Straight back.
Right on that path. All right. So. Brian, where is the intersection point of the blue, green, and red?
It's right nearly above the focal point.
Is it? All right,
Like,
I'll
not
take-
right there above it. Yeah, kind of like right there.
So we had to extrapolate to get to it because it didn't intersect on this side at all. And Brian said somewhere around in here, and I think that is correct. And I just emphasize there are tons of light rays off of all points of this arrow. This is not a light beam, it's an object, so it's a little confusing, but that's what they use. So this is, there's light beams all over. This is happening to every one of those light beams. But I'm just picking three to find, three of the easier ones to find out where the image is. So if you could use the three words then, MD, what are the three words that would describe that image? Please circle your image if you hand it in so I can know which one is the image and which is not. All right.
It's virtual.
Because? How do you know it's virtual?
It's on the right side of the mirror.
Okay.
It's reduced because it's smaller than the original.
Uh-huh.
And it's upright because it's upright.
All right. It's not upside down, so, okay. So check yours. Someone made an observation about these convex mirror images. Would you like to share it out loud today? MK, what was the observation?
They're all gonna be virtual reducing.
Right, so if you get anything else, I would be surprised. I've taken the objects all different places and it always works out the same. Different sizes, but they're all reduced. All right, so that was where we were yesterday. And where could you use a convex mirror in real life? We figured out some places you can use a concave mirror. What about a convex? What about when you walk in those little mom and pop, maybe even in the big stores, so the grocery store? Why would they have a convex mirror right there on the wall?
Because then you can see it from different angles.
Right, because they're taking the whole view and making it small so they can see you no matter what aisle you're in. Where else? What about, have you ever driven and you want to see around a corner and they stick one on a tree? Yeah, that's another type of convex mirror.
Or
So-
you can put one on your car
yeah,
on top
those
of your
little
mirror.
ones. Yeah, that's right. So I guess the passenger side mirror, does everyone have one of those? They're somewhat,
Hopefully.
everything's smaller in there, so I never wondered, I kind of wondered what that, I guess they get a larger field of vision, but everything is smaller than it appears. Or yeah, everything's larger than it appears in that mirror, closer as well. All right, we will be done with mirrors. How we doing for time? I guess we don't know.
We have 5 more minutes.
Okay, very good. I'll
About
start the next.
maybe more like 3.
All right, take out your notes from yesterday. There's another topic to be discussed on
Actually,
it. So I was
3.
hoping to get to 3 minutes.
Yeah, about.
I'd rather,
Should I just stop?
I'd rather it be too short than too long. So
Okay.
we can stop now, and when we start this new topic,
Okay.
we'll start again. So we'll be right back.
Miss Powell.